Welcome back. We've spent a lot of time on the invisible side of networking. Today we get our hands dirty with the physical layer, the actual cables and connectors that everything else rides on. A surprising number of Helpdesk tickets are pure physical faults, so knowing your cables will let you fix problems fast instead of chasing ghosts. Everything we've discussed rides on Layer 1, the physical layer, actual cables and connectors. A surprising share of Helpdesk tickets are pure physical faults, a damaged cable, a loose connector, or a run that's simply too long. Knowing the cable types lets you fix these fast, instead of wasting time looking higher up the stack at IP addresses and DNS that are working perfectly fine. The workhorse of office networking is twisted pair copper cable, terminated with an RJ45 connector. The twists in the wire pairs cancel out electrical interference. These cables come in categories that set the speed. Cat5e does 1 gigabit. Cat6 does 1 gigabit, or 10 gigabit over short runs. And Cat6a does a full 10 gigabit. The higher the category, the faster and better shielded the cable. Here's the golden rule you must remember: a copper Ethernet run maxes out at 100 meters. Beyond that distance, the signal weakens and the link fails or runs slowly. It's a classic cause of the far office always dropping its connection. You'll also meet UTP, unshielded twisted pair, and STP, shielded, where the shielding helps in electrically noisy environments like factories. Let's mention coaxial cable, or coax. It has a single copper core inside shielding, and it was common in older networks and in cable TV and broadband. It uses BNC or F-type connectors. You'll rarely cable a brand new local network with coax these days, but you will still see the F-type connector where a cable internet provider's line enters the building. Now the exciting one, fiber-optic cable. Fiber carries data as pulses of light instead of electricity. That gives it 3 big wins: far greater distance, much higher speed, and complete immunity to electromagnetic interference, which always troubles copper. Fiber uses small connectors with names like LC and SC. Because it's more fragile and pricier to terminate, fiber is used for backbones and long runs, not usually to every desk. There are 2 types of fiber worth knowing. Single mode has a tiny core and uses laser light to travel very long distances, like between buildings or across a whole campus. Multimode has a larger core and uses LED or VCSEL light over shorter distances, typically within a single building or a data center. Single mode for long hauls, multimode for inside the building. Physical faults sit at the very bottom of the OSI model, so check them first. The symptoms are no link light, intermittent drops, or very slow speeds. The fastest test is substitution: swap a known good cable, or move the device to a known good port. A cable tester confirms continuity and correct wiring. Always check the obvious: is it plugged in firmly, are the link lights on, before you reach for anything clever. Let's recap. Copper twisted pair uses RJ45 and maxes out at 100 meters, with categories Cat5e, 6, and 6a setting the speed. Fiber carries light, single mode for long distances, multi-mode for short. And substitution is your fastest physical fault test. Your task: find an Ethernet cable, read the category printed on its jacket, inspect the RJ45 connector and link lights, and write down the substitution steps to prove a faulty cable. Next time, command line troubleshooting.